Right, guys. So we are starting electricity, the new lesson. Yeah. So this is one of the physics lessons, and essay questions are there from this part. Structured essays are there, very few, but structured essays are there, and MCQs are there. Right. So overall, you'll have to uh, give a bit of a priority compared to the lessons, right? Like sort of a lesson that will come to the paper in a advanced level. Right. So electricity is supposed to understand a few of the things. When it comes to the electricity, you have to understand few of the things. Very important things are there, and it's very easy. And you already know how the actual thing in electricity works. When it comes to the theory, the actual theory works like this. How? Let's think of a mass, right? Think of a mass. So this mass, when I lift it up to this level, this is gaining sort of a energy, no? So this box now has sort of a energy, and if I release it, what will happen? If I release it, it will fall, isn't it? It will get attracted to the by a field which we call the gravitational field. Yeah, force or a field is getting attracted to the ground, right? And this energy is now working when it's getting attracted to the ground, isn't it? So when I'm lifting it up, I'm working against that field, isn't it? When I'm lifting this up, I'm working against that field, and when I lift it, the object will start to work, isn't it? The falling is working, isn't it? So there is sort of a energy transfer, isn't it? Yeah. The potential energy to the, isn't it? It's a energy transfer. The same thing happens in electricity. So what's actually happening in electricity? No. What actually happens in electricity is this, right? So inside a battery, this is what. You first listen and decide. Don't judge, right? So inside a battery, this is what actually happens. There's a positive charge, right? And positive charge contains a positive field around it. Get it? It has a positive field around it. And positive charges, do they attract or repel? They repel, right? So let's think of a positive charge like Q plus. And if you try to take this positive charge toward this nucleus or toward this positive charge, what will happen? This will try to repel, isn't it? This will try to repel, which means there will be a force acting oppositely this way. Isn't it same like I'm trying to lift this object up, isn't it? It's the same thing. Because when I'm lifting this, I'm working against the gravity. Same thing happens here. When I'm carrying this positive charge towards the center of the charge, this is trying to repel, isn't it? When I'm carrying this charge towards to the positive charge, it's trying to repel. It's the same. It's trying to repel, but I'm taking it against the gravity. Same thing happens. I'm taking this against the static force acting, isn't it? Yeah. The static charge, sorry, the static charge force, right? Static means like doesn't move, right? Make a static charge එක. මේ තියෙන static charge එක. ඒතර මම මේක මෙහෙට අරන් එනකොට I'm working against it, නේ? So if I'm working against it, what will happen? An energy will store inside of it, isn't it? When I'm carrying it from here to here, an energy will be stored, මේ charge එක ඇතුලේ. මේ charge එකේ මොකද වෙන්නේ? energy එකක් store වෙනවා. Do you understand that? Yes? ඔව් Q+ වල charge මේ energy එකක් store වෙනවා. ඇයි මෙයා කරන්නේ මොකද්ද? මෙයා repel කරන්න හදන එක. හැබැයි මම ඒකට against මෙයා මෙහෙට ගේනවා. හරිද? ඊට පස්සේ මම මෙයා එකපාරට අතහැරියොත් මොකද වෙන්නේ? It will start working like the same if I left the object ne it will work towards the ground ne same thing happens මෙයා මොකක් වෙනවද මෙයා work කරන්න ගන්න so this is a battery I'm taking as much as possible amount of charges towards the positive charge and I'm storing energy here get it I'm storing energy here that's a battery that's a charged battery or that is how you charge a battery right and when you connect two of the wires like in a circuit what will happen this battery will start to repel and send the charges throughout the wires isn't it that is running what that is running current yeah that is running a current that is how the circuit works nee? It's same as pulling an object isn't it only the medium is different right so for the charges to move it needs to have a conducting medium isn't it so if there's a conducting medium and the charges are stored like this with the energy and when the circuit is connected with two of the wires the charges will start to move and this moving charges we call it as a current isn't it and what do you call this potential energy here what do you call this potential energy of this charge here no what is the energy of this charges getting stored here called potential energy it's a potential energy yes you call it a specific name in electricity there is a specific name what do you call it you call it the voltage you call it the voltage yeah voltage bro and that's the thing you think it's hard it's not right it's you call it the voltage so voltage is what now you know the voltage right for a long time you know the voltage now do you understand what voltage actually is now voltage is what it's a potential energy stored isn't it oh pressure difference එක ඒ voltage difference එක voltage ඒ voltage difference so yeah you have to think deeply හිතන්න වෙනවා right so now do you understand what voltage is it's actually the potential energy of the charges right and voltage difference is what voltage difference is the work done here isn't it this voltage difference is the work done here isn't it the voltage difference is the work done here right so because of a voltage difference the work done by the charges is actually the current right the moving charges because or due to a voltage difference is electric current isn't it so those are the very basics of it electricity do you understand that part that's simple right so come to the theory back right electricity so first thing the rate at which charge flows in unit time is called current so what do you call a current you call a current rate at which the charge flow at a unit time right so it's simply I equals q over t amount of charges moves over a unit time right what coulombs coulomb so coulomb is the unit of charges right coulomb is the unit of charges so electric charges could be plus or minus so 1 coulomb actually is 6.25 into 10 to the power 18 amount of charges No, it's not Avogadro constant. It's a different case. This is Coulomb, right? It's not Avogadro constant. This is Coulomb. So Coulomb is what? 6.25 into 10 to the power 18 amount of charges is 1 Coulomb. Get it? Try to understand it. Huh? This amount of charge is 1 Coulomb. If this much amount, if this amount of a charge is moving in 1 second, that is called 1 ampere. Get it? 1 Coulomb per 1 second is ampere. That is 1 ampere is, right? If this amount of charges are flowing at 1 second of a time, that is 1 ampere. Get it? Right. So in the formula, I means current, and you measure it by amperes or Coulomb per second because it's Q over T, and Q is quantity of the charge which you measure with Coulomb, and the T is time, you already know it, you measure it with the second, right? If a charge of 1 Coulomb flows in 1 second, the current is considered to be 1 ampere. Do you understand that? If the charge of 1 Coulomb flows in 1 second, that is 1 ampere. Second point, if Coulomb is the amount of positive charge equal to the amount of negative charge contained in an electron number of 6.25 into 10 to the power 18 electrons. Coulomb, you measure it with positive charges, right? So there are two currents actually. One is a negative current, which is electron current. I will explain it much more. Electron current is one of the currents. The other current is positive current. The actual current that you measure is positive current, not the negative current, right? Standard current is positive current, right? And here it says like the 1 Coulomb is 6.25 into 10 to the power 18 charge of positive current, which is equivalent to the electron negative amount of this charge, right? Because the opposite of the negative is what? Positive. Make a pennanne electrons wali, but it's the same, right? So 6.25 into 10 to the power 8 electrons charge, but in positive, right? Electrons are usually negative. Make a positive කියන එක තමයි කියන්නේ. So simply 6.25 into 10 to the power 18 amount of positive charges is 1 Coulomb. That's all, right? මේක මෙහෙම කියලා තියෙන හේතුවක් තියෙනවා. I will explain it. මොකක්ද? electrons කියලා තියෙන එකද? Amount of negative charge containing in an electron number of 6.25, because there's a reason for that. Why? Because you can't actually calculate the number of positive charges, because the positive charges are there in the nucleus, right? Right. So usually this is what happens. Think this is a conductor, right? This is a conductor, right? So it has positive charges in it, or the nucleuses in it. Get it? So these are the nucleuses, right? These are the nucleuses. Oh yeah, atoms, right? And around the nucleus there are charges, or the electrons. Around the nucleus there are electrons. So if I explain simply, let's say sodium have 11 protons and 11 electrons, right? Yeah, sodium is one of the atoms, metal atoms. So it has 11 protons and 11 electrons, isn't it? It has 11 protons and 11 electrons. So usually the protons are there in the nucleus, yeah, and their charge is plus or minus. Protons are positive, they are positively charged. Electrons are negatively charged. So these positive charge, your protons, are there in the nucleus. They can't move, right? They can't move. They don't actually move. They are in the nucleus. But the electrons, they can actually move, right? So when they move, let's say one of the electron is moving, so the one of the electrons from the atom is removed, which the number of electron becomes 10. Yes, but the protons, can they move? They can't actually move, so the amount of protons are still the 11. So what is the resultant of it? There are 10 minuses, 11 pluses. That will be plus 1. So what happens here? Sodium becomes plus 1 when the electron is removed, right? Sodium becomes positive when an electron is removed, right? So the plus charge is there in the nucleus. The actual charge that was moving was what? The electron. Because the electron was removed, the positive charge came. Do you understand it? Then because the electron was removed, that is why the positive charge was appeared. Ne? මොකද මෙතන තිබ්බේ plus 11 minus 11. That is neutral. Get it? That is neutral. Oh, you can මේ electron එක ගැලවුණා. electron එක ගැලවුණාන් පස්සේ nucleus එකේ තියෙන්නේ මොකද්ද? positive charge එකක්. Get it? හරිද? එතකොට ඇත්තටම move වුණේ electron එක positive charge එක ආවේ nucleus එකට. හරිද? Same thing happens here. When you give a voltage difference, හරිද? අපි තුන් මේ පැත්තෙන් ඔයා දෙනවා voltage එකක්. මේ පැත්තේ voltage එක අඩුයි. ඒ කියන්නේ මේ ඉන්නේ pressure difference එකක් වගේ. Voltage difference in the sense like a pressure difference. Like මේක හිතන වතුර බටයක් කියලා. මේ පැත්තේ pressure high, අර පැත්තේ pressure low. It's like a pressure difference. So because of the pressure difference, actually what happens there is one of the electrons is moving out. හරිද? electron එකක් move out වෙනවා. එතකොට මෙතන charge එක මොකද වෙන්නේ? plus 1 වෙනවා. ඒක තේරෙනවද? මෙයා move වෙච්ච ගමන් charge එක plus 1 වෙනවා. Do you understand that? Yes? මෙයා එළියට පැනන ගමන් මේ nucleus එකේ charge එක plus 1 වෙනවා. දැන් එළියට පැනන්නේ කවුද? electron එක. දැන් එයාගේ මේ electron එක අපි කියන hole එකක් කියලා. You call it a hole. හරිද? මේක free electron එකක් කියලා කියනවා. හිලක් වගේ ඔව්. ඉඩක් ස්පේස් එකක්. හරි. ඒ electron එක ගැලවුණානේ. We call it a hole. So holes are positive. Right? And this is you call a free electron, right? This is a free electron. So another electron from here jumps to fill the hole. හරිද? So එතකොට මෙතන මොකද වෙන්නේ? another positive charge එකක් නේද? මෙතන electron එක මේකට පැනනනේ. ඔව්. එතකොට මෙයාව වහන්න මොකද වෙන්නේ? Another electron jumps from the next nucleus to here. So there's a positive charge. Hole. That's hole කියලා තමයි කියන්නේ hole එක. No, there's no any other name. Current. Take it in the simple terms, don't think too much. Oh, you think same electrons තමයි. දැන් මේ positive charge එක මොකද වෙන්නේ? මේ electron එකෙන් අද ඒ තියෙන්නේ මේ වල electronics වල. Don't think about it now. Think about this one. හරිද? Electronics is not this one. This is electricity. Electronics and electricity somewhat going closer, but නැහැනේ. ඉතින් මේ විදිහට තමයි අතරම වෙන්නේ. This is what actually happens here. Oh, ඒ කියන්නේ electrons move වෙනකොට now do you understand when one of the electrons are moving forward, a positive charge is moving backwards, isn't it? ඇයි ඉතින් මේ electron එක පයින්නකොට මෙතන positive වෙනවා. ඒක මෙතනින් fill වෙනකොට මෙතන positive වෙනවා. මෙතන fill වෙනකොට මෙතන positive වෙනවා. Likewise, the electron current is so the electron current is moving forward and the standard current is moving backwards. That's the theory. So there are two currents. One is a positive current, the other one is the electron current. Oh, A positive to negative යන්නේ මේ positive current එක. හොඳයි. Positive current. අපි measure කරන්නේ positive current එක. And this is how the actual positive current is moving. Get it? ඒ හින්දා අපි අර charges calculate කරන්නේත් එහෙම. මොකද charges ඇත්තටම තියෙන්නේ negative තමයි move වෙන්නේ. හරිද? ඒකින්ද negative amount එකකට equal positive charges විදියට තමයි 1 coulomb කියලා ගන්න. get it? මොකද ඇත්තටම move වෙන්නේ කවුද? electrons. එතකොට ඒ electrons number එකට equal positive charge එකක් තමයි 1 coulomb කියලා කියන්නේ. get it? නෑ. I'm telling you it because you asked. නේ ඇහුවනේ. කවුරු ඇහුවා? You asked it. අයියා අරක explain කරන්න කියලා හැව ඒකයි මම ඒක explain කරේ. හරි ඉතින් ඒක තමයි මම explain කරේ. right? So that's why you call it like that. Get it? හරි. ඒ විදිහට තමයි එන්නේ. So right, do this calculation.
amount of charge කියන්නේ මේ කූලොම් ගන්න නෙමෙයි.
amount of charge කියන්නේ
කූලොම් ගන්න charges ගන්න.
ඔව් coulomb ගන්න charges ගන්න.
ඒකේ ලොකු ඉලක්ක.
ඔව් ලොකු ඉලක්කම. amount of charge කියන්නේ coulomb ගන්න නෙමෙයි. coulomb එකක් කියලා කියන්නේ 6.25 into 10 to the power 18 නේ. අන්නේ වැලියු එකෙන් අහන්නේ. coulombs වලින් නෙමෙයි අහන්නේ. charges වලින් කීයද කියලා අහන්නේ.
6.25 10 to the power 80.
You're asking or telling me? You're asking or telling me? Calculate and see. I'll do.
power එකක් විදියට. power එකක් විදියට.
power එකක් විදිහට තියෙන that's all. charges වලින් තියෙන කොච්චරද කියලා.
දෙකට ඉවරයි.
ඔව්.
ඒක දෙකට ඉවරයි. දෙකට ඉවරයි. දෙකට ඉවරයි. ඔව්. හරි. 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 හරි.
Hari, what is the answer? 100. බලන්න. So what is the equation? I equals Q over T. The question says if a current of 10 amperes flow for a period of 10 seconds, find the amount of charge flowed during that period. What is the amount of charge on plus signs, right? So I equals what?
Q equals I.
What's happening here? I equals Q over T. So they are asking for the Q, right? So it's 10 amperes. Q over time is 10, right? So amount of Q is what? Q equals 10 into 10 is 100 coulombs. This is the amount of charges in coulombs. So they are asking just the amount of charges. Ne? So we know that 1 coulomb is how much? Yes. Amount of charges. So 6.25 into 10 to the power 18 is 1 coulomb. That into 100 is amount of charges. That is 6.25 into 10 to the power 20. Right? Easy. Right? That's a simple calculation. Huh? Understood it? That's easy, right? Easy and simple, yes. Right, come to this one, electric potential energy. We discussed it. What is electric potential is, right? When you are taking a electric charge against the electric field, that will create a electric potential energy, right? And that electric potential energy is actually the volt, isn't it? That is the volt. Get it? Yeah? What happened? Died? Still alive? Right? The amount of energy stored on the charge when carrying a single positive charge against a positive electric field is called electric potential. Get it? When you are carrying a electric charge against the electric field, it will create a electric energy or a electric potential energy stored in the charge. That stored electric potential energy is the potential energy, or you call it the volt. Get it? Right? That what you call the volt is, right? Right. So this is the charge and you are taking it against the electric field, right? This is the field, right? So come to the electric potential difference. The amount of work done in moving from one place, moving from a place of high electric potential to a place of low electric potential is called the electric potential difference, right? So the charge moving, let's say it came here, from it moving from here to here is called the electric potential difference or the voltage difference. That is the work done, yes, that is the work done, and you called it the voltage difference, isn't it? The potential difference is actually the voltage difference. So now do you understand that voltage difference is a potential energy difference, isn't it? The voltage difference of a battery is potential energy difference. Do you understand that? Yeah. So it's an energy difference. Voltage difference is an energy difference. Isn't it new for you? You already knew it, huh? No. MGH දාන්නේ gravitational energy. Make a electric. දෙකක් නේ. MGH gravitation, this is electric, right? Two different things. But somewhat similar. නේ. Energy levels වලින් ගත්තාම somewhat similar, right? නෑ. නෑ. Potential energy වාට calculate කරන්න ඉන්නේ. ඒකට වෙනම equations තියෙනවා. ඒවා calculate කරන්න ඉන්නේ. Just get the voltage, and the main thing here is you just only have to understand the theory. That's all, right? You'll have to understand the theory. That's the main thing. How things work. Yeah, right. Right. So the amount of work required to move a charge 1 coulomb from one point to another is 1 joule. Then the potential difference between 2 points is considered to be 1 volt. Get it? If the energy that takes to 1 coulomb to move from one place to another is 1 joule, that is 1 volt of a voltage difference. Do you understand that? Like if the charge is moving, when the charge is moving from here to here, takes 1 joule of a work, right? If this charge moving from here, this place to this place, takes 1 joule of energy, that means the voltage difference is 1 volt. Get it? If this 1 coulomb of a charge, this has to be 1 coulomb. If this 1 coulomb of a charge takes 1 joule to move from here to here, which that means the energy difference or the voltage difference is 1 volt. Get it? So 1 volt is what? 1 volt is 1 joule of a work, isn't it? 1 volt is 1 joule of a work done by 1 coulomb of a charge. Yes? Get it? 1 volt is a 1 joule of a work done by 1 coulomb of a charge. Simple as that. Huh? Why? Don't mix things up. Now the reason, like one of the reasons is that mindset. No, for real, I'm telling this for real. One of the main reasons for things to understand is mindset. Get it? Because if you have second thoughts all the time, if you have second thoughts that disturbs your mind all the time, you can't absorb it. This is most of the time because of the surrounding. For real, the surrounding is actually very important when it comes to the studies. If the people around you, especially the neighbors, relatives, are putting any of the negative vibes, friends, maybe the teachers even, if they are putting any negative vibes in your mind, that, and parents, yes, that you can't do, you are dumb, or you are not enough, or some sort of idea in your mind, if they plant it you as a child, that will disturb you all the time. But it's not the reality. You can actually understand it, just have to come to the metaphase. Metaphase in the sense like, metaphase in the sense like you don't think anything, you just only focus it. That's all. Yes. Yes. That is when the brain is full. That is when the brain is full. No. For that you have to have a bit of a rest and start back again. No, not the time for a rest. It's a good thing. That's one of the practices. Even I had the same practice when I was a student. So those edges from the top and the bottom, I used to write something all the time, that what I understood by this part, what the teacher taught me, and what I understood by that part, or special notes. This is something that it's not there. Sometimes that is not there in the tute itself. I take notes. So like when one page is finished, I have few of the notes like a memory map to remember what I understood there. Get it? And when you go back and when you read it, you are reading only those parts that you write, and through that points that you write, you get the whole memory back again. And that's a good practice to do, rather than yes. So it's a good thing that you take notes when you are doing. That was one of my practices. Yes. It takes time. Good thing. That's a good thing. That's a good practice. Very good thing. Yeah. I'm always telling extra than the note. Yeah. So taking notes actually helps. Where's your pen? Good. You take notes then. Yeah. Oh no. Again, it's a good thing if you can have the notes. That's active participation, That sort of active participation that you are actively doing, actively working with the things that you are studying. Yes. There is one way. අහන් ඉන්නවයි කියන එකත් one way. Listening is one of the very much important things. Listening කියන එක මටත් listening පැත්ත මගේත් හොඳයි. මට සාමාන්‍ය listening වලින් ගොඩක් ඒවා ඔලුවට දාගන්න පුළුවන්. මම ගොඩක් ආසයි අහන් ඉන්න. ඒ කියන්නේ මම discussion වලින් ඔලුවට දාගන්න ප්‍රමාණය වැඩි. මම ආසයි අහන් ඉන්න සහ discuss කරන්න. මම ගොඩක් ආස දේවල් දෙකක් නෑ. ඒ කියන්නේ අහන් ඉන්න. ඒ කියන්නේ අහන් ඉන්න එකේ ඔයාට තියෙන්න ඕන හැමතිස්සෙම දැනගැනීමේ ආසාවක්. නෑ. ඒ කියන්නේ ඔයාගේ නෑ. ඒක තමයි. ඒ අවුල තියෙන්නේ you don't have the desire to know something. නේ. ඒක තියෙන්න ඕන. දැන් මම අහන් ඉන්නකොට මට හැමතිස්සෙම ආසාවක් තියෙනවා මේ දැනගන්න. ඒතර මං අහගෙන ඉන්නෙම දැනගන්න. මං ආසයි දැනගන්න. මං ඒකින්ද අහන් ඉන්නේ. මම සමහරක් වෙලාවට දැන් සමහර අයගේ කතා අහන් ඉන්නවා. මට ඒතකොට මට ඒගොල්ලෝ රීඩ් කරතේ. මේගොල්ලෝ කියන දේවල් එක මම සමහර කාට ඒගොල්ලෝ රීඩ් කරනවා. එයාගේ හිස්ටරි එක මම සමහර කාට රීඩ් කරනවා. ඔව්. ඔව්. අපිට ඒගොල්ලෝ කියන දේවෙන් ඒගොල්ලන්ගේ හිස්ටරි එක රීඩ් කරන්න පුළුවන්. ඈ? What? ඕ ඒ කියන්නේ මෙහෙමයි. ඒ කියන්නේ ඒක මම ජජ් කරන්නේ නැහැ. I don't judge people.
මගේ history සැඩුවේ නේද?
Huh? No, I don't judge in the sense like I pay kindness all the time. I like to pay kindness that I understand the background of their selves and I eh? For a certain extent I don't say that I see I see everything. The thing I watch, like I try to or read them is to give kindness. That's the main reason, because I know why they do something if they do something. So I give kindness, I pay kindness. That's the main reason I read people. I try to read people. That doesn't mean that I read everyone completely. I can't do that. But I can for a certain amount, and I pay kindness after reading them. I try to, at least I try to pay kindness after reading them. I see your teeth are white. That's all I see. Right? So, මොකද්ද? කහ නැහැ සුදුයි. සුදුයි. දත් සුදුයි. කහ නෑ මං කිය සුදුයි කියලා. නෑ. Bro, no. Yeah. Overtaking it. No. Right, so those sort of things are there. Just me, don't worry. එහෙම තමයි. ඒ කියන්නේ මේකේ අර මේ active listening කියන එක, ඒ කියන්නේ දැනගැනීමේ ආසාව තියෙන්න ඕන. ඒක එක එක්කෙනාට වෙනස් විදිහට මං කිව්වේ ඒක මොකක් හරි එකක් එක්ක link කරගන්න. දැන් මම සමහරක්කාට ඒ read කරන ඒවා enjoy කරනවා. To understand people is sort of an enjoyable thing, but it's a different weird thing, I know. I don't tell it to everyone. But it's a bit enjoyable, but don't judge people after you read, and everything what you read is not actually true. Huh? Hey, it's creepy, yes, I know. I know. But like you have to manage it, otherwise it will be a disorder. It will be a disorder. Yeah. Oh, because the psychological disorders are even there. If you didn't manage it correctly, if you don't pay empathy and kindness, that will be a disorder. Right? You'll have to have empathy and kindness. Oh, yes. Yeah, different. Yeah. I know. I don't do that. I don't actually do that. Right? I pay always the empathy and the kindness first priority. Right? I try not to be angry and not to be hard on people when they act differently. I try to, but in some cases I do have reactions. Right? But most of the time I'm trying to. Huh? Yes, there has to be a limit for everything. Yes. So in some cases I don't. I react, but most of the time I try to. Of this, we just started it. You know? Paper. Yeah. What time is it now? 1. Okay. Yes, time for the paper. So did we discuss the previous paper? Okay, then take the paper out. Okay. So shall we break this and take the paper as another slot? I think that will be good. Yeah. Paper discussion is there to go? Okay. We'll break it and go to the paper discussion. නෑ අපිට රෙකෝඩින් එකට ගන්නකොට පේපර් එක වෙනම තිබ්බනම් හොඳයිනේ. නෑ ඒ කියන්නේ මේ වීඩියෝ එක විතරයි බ්‍රේක් වෙන්නේ. The class continues. Tell someone. So what paper was it? Paper 3 ද? Fifth? Can you show me the paper? This one. Nice. वो कभी डिस्कस करा था? Good. मैं अभी का ब्रेक कर लगा पेपर का क्या